Okay, good evening, and welcome to the third session of Ellipse. Okay, so this session we'll solve some problems before starting with the tangency. So let's go ahead. So this problem is asking us to find eccentricity of the ellipse for this ellipse. And let P be the number of all triangles that can be formed by joining the vertices of a regular polygon. P of n sides and Q be the number of all quadrilaterals that can be formed by joining the vertices of P. If P plus Q is 126, then eccentricity of this ellipse is what? All right. So eccentricity of the ellipse is going to be what? E square is equal to 1 minus B square over A square. But now since we do not know n, so in this case, we cannot have a ready-made formula. So no problem. We'll go ahead and I'll be just considering one polygon here of n sides. So now this is like side one. Vertices are going to be 1, 2, 3, 4, 5, 6, and so on up to n. N vertices we have. Now we know the number of all triangles that can be formed by joining the vertices. So for joining, this is a regular polygon. So of course, none of them are going to be collinear. No 3 points are collinear. That means to form the triangle, I just need any 3 points. So P will be equal to simply NC3 because P is the number of all. Yeah, P is the number of triangles. And Q is the number of quadrilaterals basically. So for quadrilaterals, we just need any 4 points. So that means Q is going to be here NC4. So from here we get NC3 plus NC4 is equal to, this is given to be 126. So NC3 plus NC4, we can apply the property that NCR plus NCR plus 1 is nothing but N plus 1 CR. R minus 1, not R plus 1. NCR minus 1. A bit presented here. Yeah. We can use this property and convert this to NC4. N plus 1 C4 is equal to 126. So now we'll solve this. So N plus 1 C4 is simply we can open it this way, that N plus 1 into N minus 1 into N minus 2 over 4 into 3 into 2 into 1 is equal to. This is basically 126 can be written as 18 into 7. 18 into 7 can be further written as 3 into 6 into 7. So I can write down 3 into 6 into 7. And now we can just simply compare the equations here, or else you can write down here n plus 1 into n minus 1, n minus 2 is equal to 4 into 2 will be 8, which is highest. So 8 I can write down here. And then I have next number is 7. And then this will be 6. And then we have here directly 3 into 3 is 9. So I can write down better 9. So 3 into 3 will be 9. And this will be 4 into 2 is 8. And then 7 and 6. So if I compare here directly, then I'm going to get n is equal to n plus 1 should be 9. Because if n plus 1 is 9, then the rest of them are simply following the same path because these are 4 consecutive numbers. So from here, I can write down n is equal to 8. So if n is equal to 8, then we know here we want the eccentricity of the ellipse. So eccentricity of the ellipse is simply e square. Now we know this ellipse. So n is 8. So e square is going to be 1 minus b square over a square. So it's going to be 16 minus 8, which is 8 by 16. So e is going to be 1 by root 2. So we found the eccentricity of ellipse is 1 by root 2. All right. Now let's go ahead. So we have another problem in the line, and it is asking me, let's see with the circle of minimum area enclosing the ellipse. Okay. So let's see with the circle of minimum area enclosing the ellipse this. So if we have an ellipse here, okay, say this one. Now I need the circle, okay, of minimum area which is enclosing this ellipse. Then that circle must be the director circle of this ellipse. So to solve this problem, you can consider any one of them, whether A is more than B or A is less than B. Choice is yours. We'll consider the standard one. So I'll be just drawing the auxiliary circle here because that is the circle having minimum having the minimum area. Now we can just uh, take a point here where they have given AI also. So I think A and E we have the foci and eccentricity is given. So E is equal to 1 by 2 and foci is basically A. So A is given to be what 2. So since A is 1 by 2, that means A is equal to 4. So we can find out A from here. And now since I can open this, so A square, E square is equal to A square minus B square we know. So if I square this guy, so I get 4 is equal to, this is 16 minus B square. So from here, I get B square is equal to 12. And A square would be what? 16. So we get both of them. We got the ellipse, in fact. So this point would be what? 4 comma 0. Now the question would start. So let PQR be a variable triangle whose vertex P is on the circle C. So I can just take point P here anywhere. So this is my point P, which turns out to be what? 4 cos theta, comma 4 sine theta. I can take any point here. Now what do we need? Uh, huh. And sides QR of length 2A is parallel to the major axis of E. Okay, so this is the major axis. That means I'm going to have a side QR of length 2A and contains the point of intersection of E with the negative y-axis. So point of intersection of E, this is the ellipse. That means I should have a triangle here, which this is the side is this. Its length is 2A. So this is A here, and this is also A here. That means I can consider if you're writing here 2A, that means it is basically the equal to the major axis only. This is going to be equal to the major axis only. So now I can just drop a triangle here somewhere where it will go like this. So this length we know one base of the triangle is going to be 2A. So this is 2A. Now what do we need? We need the maximum area of this triangle PQR. All right. So A we have A is 8. So therefore area of this triangle basically. So we want the area of triangle PQR. So area of triangle PQR would be what? So it's half into base is how much? 2A into height is basically just we can simply drop a perpendicular. So if we drop a perpendicular, then we know this is simply 4 sine theta. That's why. So it's 4 sine theta plus how much is this? This length from here to here, it is 2A only. No. From here to here, I need to find out that eventually this is 4 sine theta. This is my length 2A. There's nothing given here. No, nothing is given. So this height, I know it's 4 sine theta. Now I need this height. Anyhow, this is nothing but the end point of the minor axis. So end point of the minor axis, we can find out it's B. So this point is going to be 0, comma minus 2 root 3. So this is the end point of minor axis. That means I know this length. So we're going to talk about the length only. So this much is 4 sine theta and this much is 2 root 3. So I can add here 2 root 3. Now this is going to be the, we need to have a point we need. So I can add on here 4 into 2 is 8. 8 over 2 is 4 times. This is going to be here 4 sine theta plus 2 root 3. Now for the maximum area, so for the maximum area of triangle, for the maximum area of triangle, sine theta should be maximum. Sine theta should be max. So therefore, max area we get is 4 into 4 plus 2 root 3. We can take 2 even common, so I get here 8 into 2 plus root 3. This is going to be the maximum area of this triangle which satisfies such given conditions. Coming to the next. So let an ellipse with center 1 comma 0 and length of lattice rectum 1 by 2 have its major axis along the x-axis. If its major axis subtends an angle 60° at the foci, then the square of sum of length of its minor and major axis is what? All right. So here we have an ellipse. Ellipse. So here I have an ellipse, and then its center is basically 1 comma 0. So this time we have the ellipse which is shifted, and length of lattice rectum is half. So length of lattice rectum, if we consider that it's basically 2 times b square over a, is nothing but half given. That means from here I get b 4b square is equal to a. I'll keep this equation ready. Now what do you need? Uh, and have its major axis along the x-axis. So major axis is this much only. So that's not the problem. And now if its minor axis subtends angle 60° at the foci. So here somewhere is going to be my foci. Okay. Eccentricity is also not given. Okay. So this is the foci here. And now you can imagine that this subtends angle 60° here. This right here is the major axis. So it is subtending angle 60° here. That means this angle would be 30 here. So I know this is going to be basically what? If we consider the standard ellipse. So this is the end point of the minor axis. So this is B simply. And from here to here, it is AE. Though it's a shifted ellipse, but these are the ratios. So it won't change basically. So I can now find out the angle between them. So angle between them is 60°. So this angle is going to be 30°, half of it. So now we have this side available, this side available. So I can write down tan 30 is equal to opposite. Opposite is B over adjacent is A into E. So we have this thing now, tan 30 is 1 by root 3 is equal to B over A into E. And who will prefer squaring this? So 1 by 3 is equal to B square over A square E square. Now A square E square, we know it's nothing but A square minus B square. So now we have the equation 1 over 3 is equal to B square over A square minus B square. So we'll take the reciprocal here. So A square minus B square over B square is equal to 1 by 3. So this gives me A square by B square is equal to, this is going to be 1. So I'll transfer this thing here. So 1 plus 1 over 3 is 4 over 3. Okay. Might as well to get transferred here. So 1 plus 1 over 3. So 4 over 3. Now I get here 3A square is equal to 4B square. And 4B square is nothing but A. So we get 3A square is equal to A. So from here I get 3A is equal to 1. So A is 1 by 3. And so once we got A is equal to 1 by 3, we know B square. So B square is basically 3 by 4. Now what do we need? Then the square of sum of length of its minor and major axis. So we need then the square of sum of the lengths. Sum of the lengths is 2A plus 2B, this being squared. So this, when I square this, I get here 4A square plus 4B square plus 8AB. So now I can plug in all the values I have here. So 4B square is simply A. And or else it's better to plug in the values here instead of doing all the simplifications. So 4A square turns out to be 409. So A is 1 by 3 plus 4B square is 3 plus 8AB. So 8 will be here only, A into B. So A is 1 by 3, will be 1 by 3, and B is equal to root 3 by 2. 1 by 3 and B is root 3 by 2, but since there is no option with this, that means there is some error here. Let's see what's the error. Yep, in this part. The entire part became incorrect. We did not reciprocal on the right side, basically. Let's see. So A square minus B square, when I take the reciprocal, the right side also gets reciprocal. So from here I get a square is equal to simply 3 plus with 4b square. So 4b square is equal to a square I get. 3b square plus b square. So 4b square is equal to a square. Now I have 4b square is equal to a. So this is 1 and this one is 2. So if I consider 1 and 2, then I'm going to have here a square is equal to a. So this gives me a is equal to 1. So a is 1 and I can plug in here. So I get b square is equal to 1 by 4. Now a is 1 and b square is 1 by 4. So I need length, sum of length of its major and minor axis. Okay, so this is same. So 2a plus 2b square I need. So this one now we can write down here. So 4a square plus 4b square plus 8a into b. This would be 4a square is 4 plus 4b square is 1 and 8a is 1 and b is 1 by 2. So this gives me 9. So the answer should be 9 then. Now coming to this one. So the length of lattice rectum of this ellipse is 4 and L is the length of its major axis. Then lambda plus L is equal to what? So this ellipse is not in the standard form. So we'll write down here x square plus 2x plus we'll take 4 common, y square plus 2y and we'll send remaining things there. So this is lambda, add 1 here and add 1 here. So we have added 5, so we'll add 5 here. Now this is x plus 1 square plus 4 times y plus 1 square is equal to lambda plus 5. We can now write down this 4 I want to be down. So this should be x plus 1 square by lambda plus 5 root the whole square plus y plus 1 square by lambda plus 5 over 2. This will be root of this the whole square is equal to 1. Now we got the ellipse. So we just need the length of lattice rectum. It is the length of its major axis. Okay. By the way, length of lattice rectum is 4 given. So length of lattice rectum is going to be 2b square upon a. So 4 is equal to 2 times b square is simply lambda plus 5 over a is 2 here. So no problem. So this is going to be this 2 gets cancelled. No, because that's square root of. So length of lattice rectum is 4. It's equal to 2 times b square. B square is this entire part, which is lambda plus 5 over 4. And then a is again root of lambda plus 5. A is root lambda plus 5. So I can get this cancelled and write down here 8 is equal to square root of lambda plus 5. I'll keep it here. And now what do we need is L is the length of its major axis. So from here I can we will get lambda. So 64 minus 5 will be lambda basically. So lambda is 59. So if lambda is 59, then we know is the length of its major axis. So length of major axis would be 2 into a. So it's going to be 2 into root of lambda plus 5, which is going to be what? 16 basically. And then what we need is lambda plus L. So lambda plus L is equal to what? 59 plus this is length of major axis is 16. This turns out to be 5 and 5 plus 1 is 6 plus 7, 75. So the answer should be 75. So we'll now move to the condition of tangency for an ellipse. Okay, that means I have a line here. I have a line here and I have an ellipse. So we can consider the equation of ellipse to be x square over a square plus y square over b square is equal to 1. And I have a line y is equal to mx plus c. So now I want to see the behavior over this. And also I want to derive the condition when this line is going to become the tangent, it's going to be the secant, or it won't touch the ellipse. So we need to get the condition. So of course, this is a 2-degree conic. That means we can take help from the quadratic equations. So I'm just going to plug in here in this equation. and solve for the quadratic in x. So x square over a square plus mx plus c the whole square over b square is equal to 1. So this means I have here x square b square plus a square into m square x square plus 2mxc plus c square is equal to a square b square. So I can also write down 1 plus a square m square this into this common x square, and then I have here plus 2a square mc. I have here times x and then plus. I get a square c square minus a square b square is equal to 0. Now everything here depends upon the discriminant of this quadratic, so we'll find out b square minus 4ac. So this will give me 4a power 4 m square c square minus 4 times it is 1 plus a square m square into this would we can take a square common, so I get c square minus b square into a square. Now this is what I have. So the next part is if this is positive, then my line is going to because this will have two roots. So if this will have two roots, then my line will intersect the ellipse. So we'll write down there. So if b square minus 4ac is positive, so this implies line will intersect the ellipse. Line will intersect the ellipse at 2 points. So line will intersect the ellipse at 2 points. And if b square minus 4ac is negative, then line will not touch the ellipse. Line will not touch the ellipse. And if b square minus 4ac is 0, so the line will touch the ellipse. Line will touch the ellipse. And hence the tangent. So it will become the tangent. So now we can solve for this condition that b square minus 4ac is 0. So I have this last line. I need to equate this to 0. So the first task which I'll do directly here is cancel a square here directly. And I can cancel 4. So I'm left with a square m square c square. So this will give me a square m square c square is equal to this part goes to that side. So I'm left with 1 plus a square m square into c square minus b square. So 1 plus a square m square into c square minus b square. C square minus b square. Now we can simply multiply it. So this gives me c square plus a square m square c square minus b square, and also a square m square b square. And this is a square m square c square. So this portion gets cancelled, and now I get c square is equal to a square m square plus b square. This is nothing but the condition of tangency. This is the condition of tangency. That means if I have a line y is equal to mx plus c is tangent to the ellipse, x square over a square plus y square over b square is equal to 1, but only if the condition of tangency is c square is equal to a square m square plus b square. Now, and the equation of tangent also we can have. The equation of tangent having slope m is y is equal to mx plus minus c is definitely going to be root of a square m square plus b square. So that means from a point we're going to have we have to assume the equation of tangent to the ellipse having slope m. So we can assume any one of them because anyway these two tangents are always parallel. Now consider, uh, suppose I have my ellipse here and then there is a point here. So I have, from this point I have two tangents passing. I have here two tangents passing. And now suppose this is my point h comma k. Now let y is equal to mx plus minus the root of a square m square plus b square pass through a common point. Pass through a common point, or we could better say they meet at this point, say P. Common point, or say they meet at point P. H comma k. So this implies h comma k would lie on each of them. This implies I can plug in here k is equal to mh. So k is equal to mh plus or minus root of a square m square plus b square. So I can cancel this one here. So I get k minus mh square is equal to a square m square plus b square. We can open this. So k square plus m square h square minus 2kmh is equal to a square m square plus b square. You can consider all the m squares together. So we get h square minus a square into m square, then minus 2kh into m, and then plus k square minus b square is equal to 0. Now this is quadratic in m. That means ultimately we can consider that from an external point two tangents can be drawn. And the next part would be, I want to know the angle between them. So I'm more interested into knowing that if they are perpendicular. So if these two tangents are perpendicular, so if these two tangents are perpendicular, if these two tangents are perpendicular, then the product of their slopes, m1 into m2 is going to be minus 1. So the product of their slopes from here, if we find out, then this becomes k square minus b square over h square minus a square is equal to minus 1. So this gives me a square minus b square is equal to a square minus h square. So we get h square plus k square is equal to a square plus b square. This right here is nothing but the locus of P. So the locus of P, that is the locus of point of intersection. Locus of point of intersection of perpendicular tangents is x square plus y square is equal to a square plus b square, called as the director circle of the ellipse. Called as the director circle of the ellipse. So this is the director circle of the ellipse. That means if we have to find the angle of, if tangents are perpendicular and they want to know the point of intersection of these two perpendicular tangents, then I can simply find out the director circle of the ellipse and I'll be done. So this was for the tangent having slope m. Now we are interested more into getting the equation for tangent at a point on the ellipse. So let's go ahead. Equation of tangent to the ellipse. So equation of tangent to the ellipse at point P, x1, y1 on it. We now have an ellipse here, okay, centered at 0, 0, and P, x1, y1 is a point on it. So now I want to know the equation of tangent at this point. So we just need the slope here first. So I have x square over a square plus y square over b square is equal to 1. So now I'll differentiate this with respect to x. So I get 2x over a square plus 2y over b square into dy by dx is equal to 0. So from here I get 2y over b square dy over dx is equal to minus of 2x over a square. So this 2 and 2 gets cancelled, and I get dy over dx is equal to minus xb square over ya square. Now I want the slope at the point x1, y1. So therefore dy over dx at point P is going to be minus x1 b square over y1 a square. So therefore the equation of tangent would be y minus y1 is equal to the slope into x minus x1. Now we can just multiply this here. So I get y1 into a square minus y1 square into a1 square is equal to minus x1 b square and then plus x1 square b square. So now we can transfer this thing to that side, and I end up getting yeah. So I get y1 to a square plus x1 b square plus x1 b square is equal to, this is x1 b square and then y1 a square. We can transfer it to that side. So I get x1 a square plus x1 a square. It's x1 square b square basically. So x1 square b square, let's write it here. x1 square b square plus y1 square a square plus y1 square a square. And now we'll divide this equation throughout by a square b square. So I get x1 b square gets cancelled. I get a square plus y1. A square gets cancelled. I get b square is equal to, this will give me x1 square by b square gets cancelled. I get a square plus y1 square by b square. And now since this point is lying on the ellipse, so this must satisfy the equation of ellipse. That means I end up getting x1 over a square plus y1 over b square is equal to 1. This is the equation of tangent to the ellipse at point P x1, y1. Now in parametric form also we can get it. So in parametric form, we get x1 is a cos theta by a square plus y into y1 is b sine theta over b square is equal to 1. So this gives me x over a cos theta plus y over b sine theta is equal to 1. This is the equation in parametric form. Well, this is some properties of tangent to the ellipse. Coming to the first property. Now prove this one. That the locus of foot of perpendicular drawn from foci upon any tangent to the ellipse is the auxiliary circle. So this is my tangent here to the ellipse, and you can consider the equation to be, let y is equal to mx plus root of a square m square plus b square be any tangent to the ellipse. Be any tangent to the ellipse. And now there's the locus of foot of perpendicular. That means we want this locus. So the locus of foot of perpendicular drawn from focus. From focus. This is my point a e comma 0, and this one is minus a e comma 0. So basically I can consider this to be a line which is passing through the focus and perpendicular to this line. So any line, it's not basically any line, it is the line perpendicular to, so the line perpendicular to the tangent. So the line perpendicular to the tangent and passing through S, passing through S. Uh, it would have basically slope. Slope must be what? It's negative reciprocal. So I'll be having here minus 1 over n into x plus some constant we can consider c dash. Now, since it passes through S, which is a comma 0, so I can plug in here. So I get 0 is equal to minus 1 over m into x plus, sorry, x is a. X is ae, and then plus c dash. That means c dash would be uh, ae over m. So that means I get this line to be y is equal to minus 1 over m into x plus ae over m. So I can write down my is equal to minus x plus ae. So this is my line, and I have this one also. So this is my tangent, and I have this line. So this point is nothing but the point of intersection of this line and this line, tangent. So I can solve these two lines for the point of intersection. So I have y is equal to mx plus root of a square m square plus b square. So from here I can write down uh, mx minus y is equal to minus of root of a square m square plus b square. And I have the other line to be x plus my we can write down here. X plus my is equal to a. So x plus my is equal to a into e. Solving both for the point of intersection. Solving both the line for the point of intersection. For the point of intersection. So if I'm considering this fact, then better I'll consider square and then substitute. So mx minus y square plus x plus my square is equal to a square m square plus b square plus a square e square. So from here, this gives me m square x square minus 2mxy plus y square plus x square plus 2mxy plus m square y square is equal to, this would be a square m square plus b square plus a square is a square minus b square. So from here, this b square gets cancelled. And those two mxy, 2mxy also gets cancelled. And we are now left with this is x square, it's also x square, so I can keep 1 plus m square common to get x square. And the same stunt I can do with y square also. So I have 1 plus m square into y square is equal to, from here I can take a square common. This gives me 1 plus m square. So now I can cancel all of them. So we get the locus to be x square plus y square is equal to a square. And this is nothing but the auxiliary circle. This one. Coming to the next property. So this property would be the product of length of perpendiculars drawn from foci, okay, upon any tangent to the ellipse is the square of semi-minor axis. So that means we have to prove that. So we have to prove that P1 into P2 is equal to semi-minor axis square. That means it's going to be B square. So P1 is simply the length of perpendicular. That means this is my line. So mx minus y plus the root of a square m square plus b square is a tangent to the ellipse. Is a tangent to the ellipse having slope m. Having slope m. And then now I'll find out here P1 into P2. That is nothing but the length of perpendiculars. So the length of perpendicular is product. This point I just need to plug in here. So this would give me m into a, and then minus 0 plus root of a square m square plus b square over square root of 1 plus m square. This into the next one would be m into minus a, and then plus a root of a square m square plus b square or square root of 1 plus m square. So this is my P1 into P2. Now I can multiply them because they are ultimately the lengths. So this turns out to be like a plus b and a minus b. So this would give me p1 into p2 would give me the product of this would be simply m square a square e square. So m square a square e square minus a square m square plus b square. This over 1 plus m square here. And now we know what is a square e square. So a square e square is nothing but a square minus b square minus a square m square minus b square over 1 plus m square. So if I open this, then this guy gets cancelled with this, and then I'm left with minus of b square into m square minus b square over 1 plus m square. And now if I take b square common inside, minus inside the modulus carries no meaning. And then this 1 plus m square also gets cancelled, leaving me only b square. So we have proved that p1 into p2 is nothing but b square. Yeah. Coming to the next one. So this property is about the minimum length of the line segment intercepted by a tangent to the edges between the coordinate axis. Okay, so we'll derive this result and then write down this thing. Okay, so now let me draw a diagram for this. What do I mean? So here's the diagram. Now I have a tangent to this ellipse at a point, and now this tangent, it's the coordinate axis here at A, and it also meets coordinate axis at B. So the minimum length of this tangent, okay, the intercepted between the coordinate axis, that's what we need to derive. So let's go ahead. Now I'll take the point. Let A cos theta, comma B sin theta be any point on the ellipse. Be any point on the ellipse. Now, tangent at P. So tangent at P is, we have derived earlier. So x by a cos theta plus y by b sin theta is equal to 1. Now, this tangent meets coordinate axis. This tangent meets coordinate axis. This tangent meets coordinate axis. And a point we'll write down here, and b point we'll write down. So a point is basically what y is 0. So when y is 0, x is equal to simply a and y. This is y will become 0. So I'll get x a over cos theta, which we can write on a sec theta. And here on b, x coordinate is 0. So when this is 0, I get b over sin theta, which is b cosec theta. Now we want the length of AB. So AB, we can apply distance formula. So AB will be simply, or else we'll use the distance formula in square. That will be better. So AB square would be this minus this. So that means a sec theta minus 0. So a square sec square theta, which is a square sec square theta plus this is going to be b square minus b square cosec square theta. So b square cosec square theta. Now a square and this sec square theta we can add on 1 plus tan square theta. And b square would be here only. This could be written as 1 plus cot square theta. So I get to see here a square plus b square plus a square tan square theta plus b square cot square theta. So now I can consider AMGM inequality. Consider AMGM inequality. So we have here a square tan square theta plus b square cot square theta. This over 2 will be greater or equal to the square root of a square tan square theta into b square cot square theta. Now from here I get a square tan square theta plus b square cot square theta will be greater or equal to simply 2 times ab. That means I can write on this quantity as what? A square plus b square plus 2ab, which is equal to a plus b the whole square. So that means minimum of AB is nothing but A plus B. So that means this is the minimum length, okay, which is going to be intercepted between the coordinate axes. So that's all. That's all for this session. We'll see you in the next session. Thank you so much. Happy learning.